In this video, we're going to work some applications of linear functions. When we are given a word problem that includes two pairs of input and output values, we're going to use the linear function to solve a problem. Here are the steps that we're going to follow today. Step 1. Identify the input and output values. Step 2. Convert the data into two coordinate pairs. Step 3. Find the slope. Step 4. Write the linear model. By linear model, we mean write the linear function. Step 5. Use the model to make a prediction by evaluating the function at a given x value. And finally, step 6. We'll use the model to identify an x value that results in a given y value. In other words, we'll generate ordered pair solutions. Example 1. Predicting sales with a linear function. Here we have Home Sweet Home Realty. In this example, it says that Home Sweet Home Realty is an established real estate company that has enjoyed constant growth in sales since 2008. In 2010, the company sold 200 houses, and in 2015, the company sold 275 houses. So we're going to use these figures to predict the number of houses that this company will sell in the year 2024. And then for step 2, we'll graph the linear function. So we need to go back, and there are several numbers that are given. Some of these are years, and some of these are number of sales. So it's important for us to go back and take a look at what year was mentioned first. It says they have a constant growth of sales since the year 2008. So 2008 is the first year that the data is being collected. If we read a little further, in 2010, the company sold 200 houses. So in 2010, how many years after 2008 is that? So that's 2 years later. So we really want to think about how to organize this information to make the most of it. First, I would make a table to organize the year. 2008 is given, 2010 is given, and then 2015 is given. The next thing I want to figure out is my x value. Now you might be thinking, well, isn't the year the x value? Well, in a sense it is, but we really don't want to be writing these years along the x-axis of our graph. We want to use the years since that initial year for x values. So if 2008 is the initial year the data is being collected, that's actually year 0. 2010 is 2 years later, and 2015 is 7 years later. So these are the actual x values that we'll be using on the graph and to do any evaluations. Then we need our output value. So the output value would be our y value, and that would be number of sales. So we were told that in 2010 there were 200 houses sold. So in 2010, that's 200 houses sold. And in 2015, there were 275 houses sold. They did not give us information on the year 2008, so we don't write any corresponding y values there. But now maybe you can see that we actually have generated some ordered pairs. 2, 200 and 7, 275. If we have two ordered pairs, we should be able to come up with the slope of the linear function. So we're going to calculate our slope, and that is represented by our variable m. Change in y value is the numerator. So the y values, just working from top to bottom, would be 200 minus 275. Therefore, the x values will be subtracted in that same order, 2 minus 7. So it looks like the slope of the line is negative 75 divided by negative 5. A negative divided by a negative would be a positive number, and 75 divided by 5 is 15. So we know that the slope of our linear function will be 15. Now in order to write the linear function, we need the slope and we need some point on the line. So we're going to go back and think about y equals mx plus b. And we can choose either one of our ordered pairs to substitute for x and y. So we'll just go back to that first ordered pair, 2 for the x value, 200 for the y value. Since y is 200, I'm making that substitution for y. M is our slope, that's 15. X value is 2. B is what we don't know, so we'll keep that variable b. So it looks like 200 is equal to 30 plus b. Now we can solve this equation for b if we subtract 30 from each side of the equation. So that makes 170 equals b. This tells us that the y-intercept of our line is 170. As an ordered pair, that would be 0, 170. So that's how we want to think of our y-intercept as an ordered pair. So now we could write the equation as y equals 15x plus 170. Now that we have the linear equation, we could write this in function notation. Y, remember, is the same as f of x. So f of x equals 15x plus 170 is the format we want to use. Now that we have the linear function, we can go back and answer question number 1. Use these figures to predict the number of houses this company will sell in the year 2024. So the year 2024, I'll add that to the table. How many years after 2008 is that? So just take 2024 minus 2008 and you will get 16. So that's 16 years later. So if we use this x value of 16 into our function, we could answer the first question. We really are looking for f of 16 equals 15 times 16 plus 170. That means f of 16 is now equal to 240 plus 170. F of 16 then equals 240 plus 170, and that's 410 houses sold. So 410 is the output. I could write that back in the table for the y value. And that is another ordered pair that we just generated, 16, 410. Now we're ready to go over to the graph. Our input values for x tell us the number of years after 2008. Could the number of years be a negative number? No. So only 0 and positive numbers would make sense for the input. For the output values, y, this represents number of houses sold. Again, only positive or 0 would make sense. So we can use the very edges of our graph. X would be years since 2008, and our other axis is going to be f of x, which represents the number of houses sold. So do be sure to label each axis with the appropriate variable. So we have x for the input, f of x for the output, and then we title each axis. Input is years since 2008, output is number of houses sold. We're always starting with 0. So don't skip directly to any other numbers. Always start with 0 on your scale. In order to come up with an appropriate scale to accommodate all of the numbers that we need, go to your table of values. I can see I need as low as 0 for x values, and the highest number there is 16. So counting by ones is probably fine. I'll skip every other line because sometimes it's going to be a little too crowded to write all of the numbers. For the f of x axis, looking back to the table, our smallest value is 200, our largest value is 410. So I can count maybe by 25s, and skipping every other line, I'll start by writing with 50. So double check your scale. Make sure you're consistent with the counting. If I'm counting by 25s, then I have to be consistent and count by 25s. Now we'll plot all of our ordered pairs. We have 2, 200. Next we have 7, 275. We also have 16, 410. And we do have our y-intercept. Remember, we calculated the value of b, so 0, 170 needs to be included. Without that y-intercept, our graph would be incomplete. Next, we connect our points and consider whether there should be dots or arrows on the ends. So we have our line, and next consider dots versus arrows. At our y-intercept, if this line continued going to the left, that would represent negative years, so we don't want to do that. We'll leave a dot. At the other end of the line, if we continued to the right, that would mean that we're going beyond 16 years after 2008. Since that is possible, we want to make sure we extend this line and use the arrow. So make sure you're drawing an arrow for this end of the line. And you could title your graph Houses Sold by Year or something similar to that. We also might consider writing the domain and range for this application, although we really did consider domain and range when we talked about dots versus arrows for the ends of our line. It's always a good idea to consider domain and range again. The domain would be the input, or years since 2008. So the domain in this case went from 0 to infinity because we had an arrow at the right side of our line. So the domain would be from 0 to infinity, which really represents the year 2008 and into the future. The range is going to be the output. The range dealt with the number of houses sold. So the lowest number of houses sold is reflected with our y-intercept value. So that was 170. So we use a bracket to include that 170. And then as we go along our line, we can see the numbers go higher and higher to the arrow. So that is also to infinity.